In closing off this set of video lectures, I will shortly summarize what we've seen in the lectures in regards to solving nonlinear equations. So for chapter 3 of the textbook. And we started out by stating that solving a nonlinear equation can always be recast into this simple form where we just solve for f of x is equal to 0. So we want to find x such that a nonlinear equation or nonlinear function f is equal to 0. We've seen that there are two main classes of methods that can be used here. Bracketing methods, which are guaranteed to converge, or open methods, which are quite often much faster, but deal with some robustness and stability issues sometimes. Next up, we took a look into some interesting methods, and the first one we discussed was the bisection method, which is a bracketing method, which starts out with an interval containing the 0 of the function, and in every iteration we halve the size of the interval and in that way close in on the true solution of the problem. The advantage is this converges unconditionally, but the disadvantage is that this tends to converge very slowly. We have linear convergence and the error only halves within every iteration step. Next up came Newton's method. Newton's method, which was an open method in which we used the derivative of the function in order to update the current iteration and the current approximation of the solution. Newton's method proved to have quadratic convergence if some criteria were met. Quadratic convergence means that we double the amount of correct digits with our numerical solution in every iteration. So this is very, very fast. However, we saw also some cases where Newton's method failed to converge and illustrated that it's much more sensitive and not as robust as the bisection method. The secant method was introduced as also an open method, which is closely related to Newton's method. And we discussed how it is a bit more stable than Newton's method, but it's not as fast. It has superlinear convergence and not quadratic convergence. We closed off this series by talking about the F0 function in MATLAB and how that combines both bracketing and open methods in order to combine the best of both worlds, the stability of bracketing methods such as the bisection method and the fast rate of convergence of these open methods, and how these built-in functions are easy to use and should be your main point of entry when trying to solve a specific problem.